Welcome to Casting Class, the engineer's podcast for all things metal casting. Casting Class is brought to you by Batesville Products, the manufacturing experts who have been casting, machining, and polishing custom aluminum components for over 75 years.
I want to introduce our two lovely speakers today. So I have Rachel and Stephanie. Let's hop in here with the machining aluminum casting process.
So for internally at Batesville Products, you'll see that we cast majority of the time aluminum. We do zinc as well. We can go from cast, trim, and then we ship it direct. But there's also additional options that you can do with castings, which include machining, polishing, even coating, which includes wet paint, anodizing, powder coating. Some can even chromate, not really recommended on aluminum, but it's great on zinc. So there's all different types of processes that can happen to aluminum castings as well as zinc. Some that I didn't mention would be heat treating, and then also any type of testing that you need done to castings as well.
So with a lot of the different operations you see there, are there any benefits that you would say maybe for permanent mold or sand casting or die casting as you get into the conversation here around the machining?
So I would say when you're looking at machining, when you're going across sand, permanent mold, and die casting, we'll start with sand. You're going to need more what we call machine stock allowance. So you're going to have extra material so that it can allow for some variance when you're casting to going into machining. Whereas on the far end, you're looking at die casting, you're going to get probably closest to the shape you want, near net shape on the casting. So you can almost go with almost minimum to no machining on a die casting, depending upon what the part looks like. If you just need to do, you might just have to do drill and tap holes when you get to die casting. But there is one caveat, and that's the size restriction when it comes to sand versus die casting. And when you're looking at all those processes in between, permanent mold falls kind of right in the middle, like a little bit of a sweet spot where you can get tighter tolerances than a sand casting, but not quite as tight as die casting, but you can hold a larger volume part.
So talk a little bit why you would need to machine a casting if you're designing a casting coming off, out of the mold. Is it ready to be assembled?
I think that oftentimes there are instances where the parts are ready to be assembled, but often we find that our customers are in need of a features to be added or removed to that particular casting. We can talk about features such as, tapped holes, through holes, clean up the plane of the part. It may match up to another part. So that's the benefit there. And we have we're able to apply a better tolerancing there when we do machine it as a secondary operation.
Stephanie, I think this morning we actually had a really good conversation around this too. Again, you mentioned some of the hole features and reasons why you would machine from that perspective. But sometimes there's features that you need to get a casting out of the mold, or the way you need to produce it from the casting perspective, that might not be what fits for a final product. Can you talk a little bit about that?
Right. So Batesville Products specifically has a 3-degree draft that's necessary for our parts to eject from our presses. If a customer calls out for something that's less than 3 degrees, we're able to machine that material away from the casting to create the tolerance needed for our end users.
Tolerancing is obviously a very critical feature. Can you guys talk a little bit more about that side of the machining?
Yeah, sure. So with permanent mold specifically, you're going to have to add different types of tolerancing based off of the parting line. So you're going to have a tolerance that goes from one parting line to the end of the casting, or even crossing over the parting line. So for example, when you're ejecting a part, you're going to have to, essentially your parting line is going to look like this. It's almost going to come to a cone so that you can cope and drag, pull the part out of the mold. So depending upon the length of the part, you're going to have to add in more draft, less draft the longer the part is, and the shorter the part, more draft. So that's gonna be some specific tolerances you're gonna need to help eject the part. And then you can go ahead and machine some of that off if you don't need that draft. And then also, for example, when you machine a casting, you're gonna add machine tolerancing on so that you can go in and finish it to the spec that's needed. And we always say it's really important to call out what your critical features are and what is maybe okay to be as cast, because then it's going to give you, you're going to get very expensive when you start calling out more and more critical features when you get through a casting.
So the sidewall of a box could be, a certain dimension, but the machining portion of that box can be machined to the tolerance you need,
Yes.
right? So that's what Rachel's alluding to. There's critical dimensions and non-critical dimensions.
Yeah, I think we talk a lot here about the general terms of form, fit, and function, right?
Right.
A lot of times you can get caught up in the dimensioning of a part and calling out every single dimension related to that part. In reality, you're trying to get that screw hole or a tight tolerance that you machined in line with the part you're combining it with there. Stephanie, can you talk a little bit more about when a client or when a designer would explore machining aluminum casting?
Definitely the sourcing, if we wanted to talk about that real quick, Tim. Batesville Products is a one-stop supplier. We offer the casting and the machining. When an individual is maybe designing this part, they should consider its end use and would likely want to come to us after the prototyping phase so that we can institute a long life part.
Stephanie had mentioned, sourcing. So what benefits would you see if somebody is doing both the machining and the casting?
Well, you're keeping all of the quality contained to one supplier, so you're not having to manage multiple suppliers and then the finger pointing of who is in charge of handling the issue. Is it the caster or is it the machine shop that caused the issue? When you have one source, you're keeping that all under one roof, and they can more than likely solve the problem before the casting even leaves their facility. And then also when your foundry is machining the casting, they have a better understanding of how the mechanics of the casting works. So like all the different types of flex that you see when you're machining a casting. So example, when you're clamping a casting into a machine and then you're releasing it, it's going to have some of that bounce back, and they're going to understand the type of tolerances needed for when there's parts under tension versus when it's not in your machining.
So we talk materials, we talk processes. What would be some of the differences or that you would see from machining out a billet versus a cast product?
I think we can talk about aluminum bar stock for the most part,
Yeah.
Billet in other terms. Casting from ingot is obviously the permanent mold process, but on the machining side of things, that's a much longer process. It's obviously usually high dollar, especially in the long run production. So we usually advise to do the prototyping portion out of billet and then transfer that design once signed off on and the FAIs are completed to a cast situation. Tim.
And when you're talking about material differences, strictly when you're looking at aluminum and you're machining from billet versus casting from ingot, billet goes through a different process when you're creating it than it does from ingot. So for example, you're gonna have different grain structure when you're getting a machine part from billet, as well as slightly different mechanical differences. Granted, I'm not a metallurgist, so I'm not gonna go into the details of it. But then when you go so it's gonna have a linear structure because of the way it's extruded and creates the ingot, or the billet, I'm sorry. And then the ingot, since you're casting it, it's going from a flow state, liquid state into a solid state. So you're gonna have flow pattern and lines when you're casting from ingot. So you're gonna have a different grain structure. So, and there's also gonna be more gas in the cast part than there will be from a machine from billet part.
Not all materials are going to machine the same. So when you're talking billet from ingot, But even if you're talking, what you had mentioned earlier, A356, and then you heat treat it, it's still going to machine differently, even though the material composition of that aluminum is still the same. There's different impacts that you get from those processes as you continue down the line.
And not to negate the fact that a machined part would also have to be heat treated as well. If it's from 6061 or 5052, that item after creation would have to be heat treated.
Yeah, I think that's a good point, Stephanie. Obviously, we do a lot with 6061 from a fabrication, a billet perspective that is extremely comparable to a A356 cast material, or what you would see as a A380 in the die casting. Can you guys talk about the differences you may see from a design perspective?
For machining from billet, you're gonna be limited on the size of the ingot or the size of the billet that you purchase, and then also the footprint of the machine. But with that being said, you can get down to extremely tight tolerances when you're looking at a machine from billet part, but you're also gonna get cost that comes with it. Now, when you're machining from a cast part, you're looking at a different size range. So you're not limited on the size of the casting unless you're looking at a specific casting process. For example, you can cast as large as you want when you go with a sand casting. But with that being said, there's features that are going to have tolerance requirements so that it can cast properly that you're going to have to go back through and machine out. But that being said, you're going to have a lot less machining to do and a lot less material waste because you cast to shape and then you machine in the features after that you needed. Whereas when you machine from billet, there's a lot of material waste that happens. So a really good example, I've got a part right here. This part right here, if you were going to machine it from billet, you're going to have to waste all this material that comes through the center. Where if you were to cast it, you can either cast it with a sand core to get the internal feature, or you can do a steel core and then machine away the draft. But there's machining that's going to be required with that, but it's going to be a lot less material waste. So that would be one good example of why you would want to choose a casting for this.
Yeah, and I think absolutely, Rachel. And just on a side note, Tim, I think that it allows the end user to increase the quantities relatively much easier in a casting situation as opposed to a machining situation, just because of the cost of machining in general. And then you obviously have that repeat in quality on the casting side of things. Not to say that machining isn't, but definitely when you get to the high numbers, that's where you'd find the cost savings.
Yep.
With that being said, it sounds like there's pros and cons to both. Can you guys talk a little bit more about why and when you would choose one process versus the other when it comes to billet or casting?
I think really it comes down to quantities is really where we see the difference. You see a return on investment essentially with one process versus the other. So you're not going to want to tool up if you're looking to make 3 to 5 parts in the whole lifespan of the product, to a certain size extent, of course. But for example, prototyping would be a great way to go forward with a machine from billet. But I will have to kind of say there's a lot of foundries out there who are now starting to do 3D prototyping, so they can 3D print sand molds pretty easily so that you can cast the part for prototyping. So I think really one is quantities, and the complexity of the part really drives what process you're going to choose.
But while I was just going to speak on the material waste, so the green initiative is to have a material that is infinitely able to be recycled, not only at its end of its life, but at the beginning of its life. So if we're not machining out of billet, we are casting these items, there is very little waste. Obviously, if we had a reject part, we just remelt that immediately. From the machining side of things, when we're creating waste, it's hard to recycle with the coolant contamination, et cetera, et cetera. So definitely thinking about what's a really good way to help the environment, right? Through the casting, especially as Rachel mentioned, with the higher run quantities that we've been seeing. And if we remove the prototyping aspect of it, or the low run quantity, if you have 10 parts and you're making 10 parts and you're using a machine billet, that makes sense. But at anything over a high run quantity, tooling up a permanent mold for your particular part is the way to go.
And also the life cycle of the part. So if you're ordering multiple hundreds of thousands of pieces a year for a span of 20 years, investing in a tool in the long run could be potentially more cost effective because you're going to receive a return on investment through the life cycle of the part, whereas you're going to consistently have a higher piece price when you machine from billet.
Mm-hmm.
Can you guys talk a little bit more from the fabrication to a casting side of things?
Sure. We'll start off by showing a part that we went from fabrication to casting. So when you're having to weld multiple components together, you're spending a lot of time in assembly. Whereas if you could cast those components all into one piece and then just machine the critical features, you're saving a lot of time in processing and labor. So for example, this part, you can create a up to 6-parted tool so you can get a pretty complex shaped part. That way you're reducing your end assembly time when it comes to creating a casting or your design you need for manufacturing.
Yeah, I would say, just to tag on to what Rachel said, you're removing all aspects of fabrication. If you transfer your design to a casting, there's a lot of applications or operations that are involved with creating a fabrication, whether it's steel, aluminum, stainless steel, etc. As noted, we have your welding, laser, water jet, the burn tables. Those are high dollar operations with skilled employees who are much needed in a maybe a lower run type situation. But when we go to the high volumes, which Rachel and I spoke of earlier in the session, there's definitely a cost savings there. Talk about quality, talk about repeatability, the castings.
Hit a question from David here. So how does the design of the mold change or affect how you machine different features of the part? Can it become more problematic? A little bit more detail. Can it become a little more problematic if you run into porosity or potential air pockets?
Definitely. So if there's going to be inconsistency in wall thickness, you're going to run into flow issues. So there's ways to work around it to make sure you're not getting any shrink or porosity. So we can add on gates and risers and venting to help allow the mold to fill out more evenly, but you will run into potential issues with that if you are requiring different wall thicknesses. But really what's great about casting is you can cast in features and then again machine away. So Stephanie has a really good part right here where we cast in all of the fins and then we even have a window where we can go and machine it down to the correct size it needs to be. So you can cast in a lot of those features and then go in and even reduce the wall thickness by machining away certain areas.
You're going to run, castings are naturally porous, right? You're going to run into areas of concern or that may be a potential on the machining side. And what we try to do is really look at the preventative. So looking at the FEA and solving that out, looking at air entrapment possibilities in a mold, or looking at, the flow, the rate your gravity feeding the product. Again, back to the composition of the metal, you're testing the metal, you're gassing and degassing the metal, your different temperatures. There's a lot of different variables that go into solving it. But really understanding, and I think it goes back to some of Rachel's and Stephanie's earlier conversation around if you have a facility that understands castings, understands machining, understands polishing, heat treating, coating, if you can get somebody that understands all of it in one breath, you're going to have a lot of expertise on your hand. Whereas if you're dealing with just a casting company, they really understand the casting, which is great. But may have some limited expertise in helping you design the machining side or further operations.
Yeah, Tim, I think that's where professional engineering team comes into place, right? So anybody that does business with BPI has our engineering team as a resource to help guide them through the design and all the features that Rachel just spoke about.
Thanks for listening to Casting Class, the engineer's podcast for all things metal casting. For more episodes, videos, and guides, check out BatesvilleProducts.com. See you next month.